This video is to talk about a few rules for convergent series. And the rules are simple, and in some sense, they're common sense. So the assumption is that the summation of Bn, that series, is equal to B. So what I'm saying is it converges, and it converges to a number. And the summation of An is equal to A. So it also converges, and it converges to a number. Well, then what does the series An plus Bn converge to? Well, as you might guess, it's going to converge to A plus B. What does the series summation of C times An converge to, where C can be taken to be any real number? The answer is, and I bet you would guess, C times A. And finally, you've got a result of convergence series that says this: if the series converges, that is, the summation of An is equal to A, then the limit as n tends to infinity of the A sub n term has to be 0. By the same token, if the series Bn converges to B, then the limit of the nth term has to be 0. Now you have to be careful because the converse of that statement isn't necessarily true. That is, just because the limit of the ANs is 0 doesn't mean the series converges. Soon we'll find examples where the limit of the ANs is 0, but the series doesn't converge at all. In fact, it diverges. All right, so now let's look at a few examples about how you would apply these rules. Let's look at a couple of geometric series. The first one is the summation n running from 0 to infinity of 2/5 to the n. Okay, that's geometric. What's R? Well, R is the ratio, and it is 2/5. What's A? Remember, A is the first term. And in this case, when n equals 0, the first term is 1. So a geometric series, what's its value? Well, it converges when R is less than 1, but R is 2/5. That's less than 1. So it converges. What does it converge to? A over 1 minus R, which in this case is 1 over 1 minus 2/5. Of course, 1 minus 2/5 is 3/5. And if you flip it, you get 5/3. So that series not only converges, it converges to 5/3. The other series is 6 times 1/3 to the n. Well, that's n running from 0 to infinity. It's not hard to see what's R. R is 1/3. What's A? A is the first term. When I plug in n equals 0, I get 6. So this series converges to 6 over 1 minus 1/3, or 6 over 2/3, which is 6 times 3/2, or our final answer is 9. So, looking at an example of I, what's the series of? The terms are 2/5 to the n plus 6 times 1/3 to the n. And the answer is, what this really says is that you could break up the sum into the sum of 2/5 to the n, add the sum of 6 times 1/3 to the n, and as long as these two series converge, then so does this one, and it converges to what? The sum of the two answers. 5/3, add a 1/9, which I believe is going to be what? 27/3, add 5/3, 32/3. Okay, now let's look at a case of 2. Suppose I wanted to compute the summation of, here's my terms, 12 times 2/5 to the n. Well, one way I can do that is, what this really says is that I can factor out that constant 12. So it comes out, what's left is the summation n running from 0 to infinity of 2/5 to the n, which we already said was what? 5/3. So I get 12 times 5/3 or 20. There are a couple of examples then of how you use properties of convergent series to compute some values. Just a couple of warnings. So it is true, part 3 says, if a series converges, then the limit of the a sub n's has to be 0. Again, I want to say, though, that the converse isn't always true. In other words, just because the limit of the a n's is 0 doesn't mean the series has to converge. But the contrapositive of this statement is in fact true. What's the contrapositive? If the limit of the a n's is not 0, then you can tell me the series diverges. But that's about as good as you can do. All right, so there are a couple of properties of convergent series, and that's all I'm going to look at in this video. Bye.